If you want to build better and faster React Native applications in 2024, you want to use local first, and I will show you exactly how with PowerSync in this tutorial. What's up, galactic friends, and welcome back to a practical tutorial on how you can transform your React Native application from a standard default application to one using local first. There's another video on this channel that you should probably watch before this. It's called Local First is the Future or something like this. I will put a link below this video, so go watch that, why you want local first in the first place, and then you can come back to this one because here we will get practical. In this video we will take an existing super simple application that's using Superbase as the background, but could also use any other kind of Postgres database, and then transform it to a local first React Native application using PowerSync. And speaking of PowerSync, PowerSync is also the sponsor of this video. PowerSync is the sync layer between your app's SQLite database, which is really fast, and any kind of other Postgres database. As I said, in our case, Superbase. You can check it out at powersync.co. You can get started for free and create an account. And with the PowerSync SDK, you can exactly control how your application is syncing specific data to PowerSync to your backend, and PowerSync really just sits in the middle as a sync layer without messing up any of your front end or your backend. So if you want to support me in this channel, make sure you check out powersync.co or use the link below this video. Thank you for sponsoring this PowerSync, and now let's get practical and transform a React Native application from only using Superbase to using PowerSync and offline first. Alright, so let's start with a quick look at an existing application. You can check this out simply from GitHub. It's in the React Native local first repository linked under this video, and you want to make sure that you go to the initial app branch and check that one out. Once you get that, you also need to set up a database within Superbase. I'm pretty sure you know at this point how to create a Superbase instance, and within the repository you can also find the SQL command to create a to-dos table, also a users table, and some other fun. And at the end, actually most of this is not really required, but it's like good practice. And we already have a little line here which you will later use for PowerSync. You don't need to run this for this example right now in the beginning with a Superbase connection, but we would need it later, so just run this. And then make sure you update your environment with the Superbase URL and anonymous key. And then you should have your application pretty much up and running. This is a super simple example of using Superbase. We have authentication, so we have a login page that I already skipped. And then we have this input here, so I can add something to this, hit plus, and it would be added to my list. It's not done. I can swipe this, I can delete this, I can delete this. If I swipe this, how can I, I probably need to fix a little thing here so I can mark this as checked. However, if we check out the rest, let's see, build great apps, I will delete this, and pretty soon after it's deleted from Superbase. So super simple example of using Superbase in our application. Most of the logic is here in the index, it's protected in the auth folder, but all of this is really just basic stuff of using the Superbase JavaScript SDK. We have a select statement, we have, here's the select statement actually, here's the add statement for adding something, we probably have the update statement here, update something, and then we have the delete statement. So really the basic CRUD functionality is implemented with Superbase. And this is a good example because we can now focus entirely on the transition from making this application using only Superbase to using PowerSync and local first. If we now want to transition our application from purely using Superbase as the source for the data to a local first architecture, we can bring in PowerSync. So PowerSync is like a sync layer between your Postgres database and a SQLite database in a device. Why? Because all mobile devices do have access to a SQLite database, and it's usually really fast. Check out my other video I did on this topic about why you want to go local first in the first place if you're still not sure about it and how PowerSync works. By the way, I'm actually also in here, which is quite nice, so thanks for including me. But what I really want to show you is how and what the steps are that you need to take to go from your existing Superbase project now to including PowerSync. There is actually a great guide. So once you go into the PowerSync documentation here under integration guides, you can find a Superbase PowerSync guide. That one is pretty great if you're interested. We're gonna follow a pretty similar setup here, and it shows nicely. Can we zoom into this a bit more even? The architecture, and that PowerSync is simply here in the middle between the data. So it's not messing up your Superbase, it's not messing up your client application, it simply sits in the middle as the sync layer. That's really how you can picture PowerSync. As I said, we're gonna mostly go through these steps, but follow them a bit differently. So let's keep this behind. You can open it up if you're interested, but more importantly is how we now configure our project. So get started at powersync.com. You can create an account for free, and then you should be inside your dashboard. So initially I had some issues with this. I just want to quickly notice a few things. So we got our project up here, where we got our default workspace, and we got like 3 separate columns here. You can also have multiple. It is pretty much like a code editor that you can configure to your needs. So if you go up here, you can find different panels. And you can go, for example, down here to panels, and it would open up this view. If I now am interested in, say, the history of my stuff, I could actually click on it and it would open up here, or I could then drag it around into a different view. I could replace this. I can close this one. So if you click somewhere to close a panel and you're afraid you're not getting back your instance status, for example, I do it like this, then you could go back here. I could search for instance status, I can click it, and it comes up right here again. Same way, I now want to get my project settings, so I go up here and click PowerSync project. Okay, this is just some general stuff about the UI that I think is going to be helpful. But now I want to create a new instance, so click up here to create a new one. I will call this one Superbase/video and hit continue. Now this creates my new instance. Region, it doesn't matter too much. I could also use you. More importantly is the database connection. So I want to now add a new connection, and I want to connect this to my instance here, my Superbase Postgres database. So I will go under the project settings, under database, and I'm going to disable the check mark here. Okay. So you don't want to use it with display connection pooler. You just want to copy that URL, go back to your project, and then you enter it right in the URI place. This is pretty cool because based on the URI, it will then simply extract most of the relevant information. Only the password is still required. So when you created that Superbase instance in the first place, I took note of that password, and I hope you did as well. And I will now place it in here, hit test connection, and if I did everything correct, we see connection success. Additionally, one more step, go to client out and hit use Superbase auth, because we're using Superbase, and of course we're going to use their authentication. Save and deploy, and then we can already click on this, and we should see it's deploying, and that is totally fine. Now, the next step is to go into my sync rules. So the sync rules are really important, and because they're important, I'm going to place them here in the center. I'm going to do replace. Okay, nice. Now we got more space for my sync rules. By the way, what happens if I close this? No, I want to just, I really like to play around with this. It's so interesting. So here's the power to do. That's actually my first instance I had. And down here we see running for my second instance. In the sync rules, we don't have anything yet. You haven't seen that. We want to type these together so you understand what they are. So the sync rules basically tell PowerSync how and which data to sync from Superbase to your client application. And we write these together. So we have a bucket definitions file. And within that bucket definitions file, we define the different sources of data for our application. So in my case, I only have like user lists of data. Within these lists, we're gonna have specific data available. So you see nice formatting here going on. So select star from to-dos, which was my table. And now it's important that we can structure these with additional data. So I don't want to get all the to-dos. That wouldn't make sense. If person A gets all the to-dos from person B, C, and D as well. So we're gonna actually include a where case here. Select star from to-dos where user underscore ID is equal to something. So with or at this position, we need the information from the Superbase authentication token. And we can actually extract this. We can define our parameters up here, and we can say select token parameters dot user ID, and it actually comes as code completion in here. And then I can also give this a name, so I will say as user ID. You could also say as my ID or as Simon's ID, whatever. This is just the ID that will be available to us now. And then I can use this value or this name or this value as the name inside my query here. So select star from to-dos where user ID is equal to user ID. Let's try and validate these on my instance. Validation failed. Query must cover all bucket parameters. Where did I go wrong here? Oh yeah, this is not how you do it. It is bucket.userid. Now I go validate again, and it caught my issue. That is also pretty nice as well. Like missing bucket here, if I wouldn't have gotten any error at this point during the validation, that could have gotten me really into trouble later down the road. So next step is to deploy these rules. So I click deploy continue, and the deploying is in progress. So it's pending right now. While this is pending, let me show you one more thing. So we did all of this here in the web UI of my PowerSync project. However, since I think just a week ago, you can actually use, next to PowerSync Cloud, you can self-host PowerSync. Okay, there's a nice documentation in how to get started here, and I actually had previous access to this. This was really, really interesting. So it was a nice repository I got access to in which I could configure everything locally. So I had my local PowerSync file, I had a local sync rules file. This project also included a demo backend and demo app. I had to use Docker, and I was actually able to do this. I really have to laugh because I'm not good at using Docker. I don't really understand what's going on, but I was able to spin up this local to-do list where I can like update data. You can also use the SQL console and check out what data is included. You can execute queries in here. You can fake things, and you can go back to your to-do list. So while this is probably not super spectacular in itself, the fact that you can now self-host PowerSync is going to be really, really helpful for a lot of companies, because I know in many cases companies are like, yeah, we like that tool, but we can't use it because of policy XYZ. And if these companies now have the ability or the chance to self-host PowerSync, it opens up a whole new perspective for you. So if you're interested in more than just using the PowerSync Cloud, check out the self-host option of PowerSync. Okay, meanwhile, we can close the Supabase guide. We got this. My Superbase video, yeah, error and warning, it's being deployed, so the operation is still running. That's pretty good. While this is still running, we can actually copy over the most important piece in making sure that our application is connected to PowerSync. So I'm gonna right click here on my instance and hit edit instance, and there's is the URL of truth. Go ahead, copy that URL and go back to Visual Studio, not the self-host demo, but the React Native local first demo. And within my env file, I have this new key here, expo public PowerSync URL, and I'm gonna place in my URL. So this is how our application will connect to PowerSync and through PowerSync sync and keep the data in sync. Good. Let's close this one here, and we see nice instance deploy logs. It is completed. That is good news for us, because the next step is now to include the SDK for React Native in our application. There is the client SDK reference here. You can check it out. Most importantly, you have to open the SDK's README. And within that README, let's zoom in a bit, you're gonna find a lot of installation logs. So you wanna run all of these. You wanna install the PowerSync React Native SDK, of course. It has a peer dependency to a specific SQLite implementation from Journey Apps, the company behind this. And then there are a bunch of polyfills, so React Native polyfill globals, and a bunch more here that you want to copy in. We will take care of adding the polyfills later, so you don't have to worry about that part yet. Also, this is something you don't really have to worry about. Also, this one, we're gonna handle all of that later. However, there's one more thing I want to point out, and that is that I wanted to include something additional. So this is Keysily, the type-safe SQL query builder for TypeScript. Why, are you probably asking yourself? And that is a good question. So if you check out the current implementation in the Superbase initial app branch, you're gonna notice that this stuff looks pretty cool. So await from Superbase insert to-dos. However, as you might have seen also in my previous video, once we go to the PowerSync implementation, we could have like a watched query in here where we have raw SQL statements, select stuff from whatever, where equals. And I know front-end developers are not particularly interested in using SQL statements and queries in their front-end application. So to make this or your life a bit easier, we can install Keysily in our application. You simply go ahead, let's open this up, and you run npm install PowerSync Keysily driver and the Expo crypto package for our application. Let's hit enter, and then it can run in the background. So once you got this, once you got the PowerSync SDK installed, you got Keysily installed, and you see that your application is working with your PowerSync, with your Supabase Postgres database, and you copied over the URL into your environment, we can take on the transition of our Superbase application to a local first application with PowerSync. This part is probably now the most important but also most challenging of this tutorial. So let's see how we can set up the files in our application to transition now from Superbase to using PowerSync locally. Let's start by creating a new folder. I just have to click somewhere else, and I will call this folder PowerSync. There are a few good examples in the documentation of PowerSync about the different files that we need. So we need to set up like an app schema, we need a Superbase connector. Actually, that file is pretty good. So I found this from the Superbase PowerSync example. There's a repository connected. Actually, we're gonna just take this for now as a good baseline. I think you're gonna find this example many more times in the documentation. Let's call this Superbase connector.ts, and I will put this in. We're gonna have to fix a few things because this is not working entirely as we expect, but this is something we need to provide to PowerSync to connect to Superbase. And you can imagine this would be required in a different way if you would use like your own Postgres instance somewhere else. Then you would have your like my backend connector thing, which just needs to implement the PowerSync backend connector interface. Probably it's a good idea if we set up all the required files. So we also need to have an app schema.ts. This file is actually pretty easy as we need to simply define how the local table in SQLite will look like. Maybe we can just quickly do this because it's actually a pretty short file. So let's say we have our to-dos table, and I want to call this one to-dos. Then we generate the interface here or the schema by using new, and I will actually use table v2. There's also in the documentation usually something about the first version. So if you check out here, this is or would use the default schema. So you have like a table name and columns and indexes and whatnot. However, since we're using Keysily or whatever you want to call this, we're using table v2, which will make this a bit easier. And now I just need to pass in an object here. And we just need to pass in an object that holds the information, again, column.text. So the task is a text. Then we have a user ID column. That is also going to be a text, and then we have an is complete. That might be a boolean, but actually I think column.boolean doesn't exist. So we only have in SQLite integer, real, and text available. I will make this an integer for the moment. Then we're gonna export const app schema. So this is a new schema now from the PowerSync React Native package. And we just include my table that we created, which is the to-dos table. If you add more tables, then these would be included, of course, in the app schema. And then we can export two types, which look like this. So we have export type database, and we have the export type to-do. This is our local app schema for SQLite and using it locally. And we can then combine the app schema and the Superbase connector, which we will fix in a second, within the actual PowerSync.ts. So this is like the main file that comes and brings together everything. We probably have a default for this. Yeah, it could look like this. Usually it looks a bit different, but let's copy this just for the moment. Okay, so it brings in the database open factory, it brings in a connector. Again, this is just the general idea of what we want to do in this file, and then it creates the connection with the database file name locally and creates an instance of this. In our case, we're going to do this class-based and a tiny bit different. So let's do this together. Export class, we're going to call this system. I found this in the documentation a few times. We're going to have a Superbase connector of the type Superbase connector. So we're not using my utils. We will actually use the Superbase connector. We just need to like fix that. Then we're gonna have a PowerSync instance in here. So PowerSync, this is going to be an abstract PowerSync database. And because we're using Kaiseli, we're gonna have also this specific database in here. We need to import this from PowerSync Kaiseli driver, and then we can specify that this has the database, which comes now from my app schema. So this gives a strong typing for the Kaiseli database. Now we need a constructor here. We need some code that's pretty accurate. So we're going to start with the code that we just saw a second ago by using the React Native PowerSync database open factory. We pass in my app schema. We need to import the app schema. This is actually the Superbase connector. Now everyone gets happy, right? We're getting rid of the red lines. That always feels good. We're initializing a new Superbase connector. I will not pass this. Don't worry, we're gonna fix the Superbase connector in a second. We will set up PowerSync. So this .PowerSync using factory dot get instance, what we just had like seconds ago, get instance. And then we're gonna set up the database by using the function we got from the PowerSync Kaiseli driver, which is wrap PowerSync with Kaiseli, and then input this .PowerSync. Good. Okay, this is pretty good for the moment. Let's just add one more thing. We're gonna have an init function here that will actually initialize the whole fun. So within this, we're gonna call PowerSync init, not open, and we're gonna call this PowerSync connect to connect to our actual instance. Connect using the Superbase connector. And then we finally add 3 more lines down here, which will help us using context and using this as a hook. So we can then simply use system and get access to like the PowerSync connector or the database in all the files that are below that connector. Use context from React as well. Again, don't worry about that last red line. We're gonna get to the Superbase connector fix in a second. Almost the last file we need, and I think, okay, we need 2 more files. So we need one file, which is this UUID function. This is just some code you put in. So export star from crypto and then return crypto random. You actually don't really need that file. You could also directly call this in your app, but I wanted to put it just like they had into its own file so it becomes a bit easier. But what we want to do is, I want to do this in the React way. So I will create a provider that we can then wrap around our app. We could have also probably done this in here, but I think it's a bit clearer if we do this in another PowerSync provider.tsx file. So here we create our PowerSync provider. We don't really need this right now. We got some children. We can also use some typings in here actually, or the correct type for that matter. So if you want to get this right, what you can do is you can have an object here, children, and these are React Node, and then everyone's happy. Okay. And what we're going to do in here is we use the hook. So we use the hook to get the PowerSync instance using use system. That's what we call that hook. And then we create a DB or get that DB by using use memo. So we're memoizing the connection here. We're going to call return PowerSync without the DB. And then we close that off, empty dependencies array. We don't need anything in there. And here we go. And finally, we can return the PowerSync provider. Or actually, yeah, we're using the PowerSync context in here. And the value is my database. So we can then wrap this provider around our application and we have access to the database and PowerSync in all of our files. That is the whole idea we have. Now, for the last part, we need to fix my Superbase connector. So let's go into the Superbase connector now. And let's see. First of all, we can remove, I don't really have the app config. We're actually also not using Superbase storage in this. So I will remove all references to storage. And then I'll also remove system in here. However, what we need is to get the relevant data. So I want to get the Superbase URL, anonymous key, and also the PowerSync URL from my process.env, just like we're used to with Expo. So make sure your .env file is set up correctly. On top of that, what we also need is the async storage, because this will be used to store our token. We already used this before. So if you check out the previous Superbase.ts, you're gonna find pretty much the same code in here. Also, the React Native URL polyfill needs to be included in here. Now let's see, let's scroll down a bit. As I said, we will not use Superbase storage. And also the constructor does not really require the system to be fed into this. So I can remove this. This.client is now equal to create client. That's the usual function from Superbase. That's correct. We don't have the app config, as I said. We just have a Superbase URL and we have a Superbase anonymous key. And then we can leave this out and just have persist session. I think this is the default, by the way. And I want to set the storage here to async storage. So Superbase is storing our auth key in async storage. Then we have some functionality here that we will later use to log in to make sure we're not only logged into Superbase, but also syncing this correctly with PowerSync. So these are the functions, log in, and we have fetch credentials. There's one more things we need here. So you see endpoint is now not app config. You could have probably created this kind of app config thing. And I also in my example returned this.client here. I don't know if this is required, but I will just do it. Then we have upload data, which will upload some database transactions. Again, this can stay entirely as it is. You don't have to write this. These are some defaults from PowerSync. And with that in place, let's close that file and go back to my PowerSync and we see everything is green and happy. There are just two more things. If you follow the SDK installation, you're gonna see at some point they add the Azure Core Async Iterator polyfill and also this one. So add that to the top of the PowerSync file and then everyone is happy. Good. So this is pretty much the end of connecting our app to PowerSync. You should now have this folder with all the required files. And once you got this, we can now take the last step, which is rewriting our app from Superbase to using PowerSync. All right, so I've restarted my npx expo command because we changed our environment file and I'm always scared that it's not picking up the changes. So make sure you probably also test this. But at the moment, what we see is that we're still getting all the data automatically here in Superbase because we actually haven't transformed our application to use PowerSync yet. That will change now. So we're going to start at the topmost level in the layout file. And in the layout, we're going to go down and probably start by defining a root layout, which will wrap our application. So within the root layout, I want to use my initial layout. So I will return, actually we could have done this differently. If we just use these brackets, we don't even need a return statement as far as I know. And then we can use our PowerSync provider. So make sure you get the right one. We wrap it around the initial layout, and then we're going to change our export default to use this one. This shouldn't change our application. So we're really going to try like a doctor to just piece out the different tiny steps in the most, like the smallest invasive way. We don't want to destroy our app and you have a huge migration. I really want to go through the different steps here. Now what we need to do is we don't want to use Supabase directly anymore in our application. That means all the references to util Supabase should be removed. And instead of that, we're going to use our Supabase connector. So let's get the Supabase connector using use system, which is the hook we implemented before. On top of that, we also want to have direct access to the system. So we can also use, can I do this in one line? Like system, use system? Nah, I can't. I'm not that good with TypeScript, I'm sorry. Okay, then we're gonna change this line here to Supabase connector. And now we're gonna check. So Supabase connector dot client is the actual client that we wanna use, okay? Supabase dot client, and then we have .auth. So then we have all the authentication stuff available, and this turns green again. On top of that, do we, yeah, we should probably do one more thing, and that is something I completely forgot in the beginning, and that is adding a use effect block here to initialize my system. So right in the beginning, I have to call system init. If you don't do this, if you forget about these 3 lines, everything that you do won't work, and you're gonna have to debug for hours, which probably someone called Simon did. Okay, this is crucial. This initializes the connection to PowerSync and makes sure it connects correctly to Superbase. So please put this in somewhere in your app. It doesn't have to be at the topmost level. Maybe you're having some other kind of setup, but this needs to happen somewhere. And if you don't do this, you're gonna get into a lot of trouble like I did. Then let's continue. We do have actually an index page for logging the user in. And again, that page is of course using Superbase from utils Superbase. So we're gonna change this. We're gonna bring in my use system hook and also the Superbase connector, and we can go through these lines again. So we will actually not call sign in with password. What we instead want to call here is, let's change this function from on sign in press like this to using the Superbase connector login. This will under the hood call sign in with password as we implemented in the connector. So if you're using different login mechanisms, make sure you implement that correctly in the connector and you're funneling the calls through that connector instead of directly interacting with the Superbase SDK. Okay. For the sign up, we don't really have anything specific going on. So in that case, I can just replace this with my Superbase connector.client auth sign up. And the rest of the view can stay entirely the same. Let's see, if I now refresh my application, we would now use my code through the Superbase backend connector. So I think I use simon@galaxies.dev. Let's do a wrong sign in. Okay, invalid credentials, so that's great. And if I log in, I am logged in with Superbase. So you've seen a failure and a success at the login, and we are not using my utils file anymore in here. Good, these were 2 places, 2 more left that we need to fix. So if we check out our internal layout and index, in the layout file, I think I had something like a sign out. Yeah, right, here I'm calling Superbase auth.signout. Let's change this to a different system. So I'm bringing in my use system. I will use the Superbase connector once again. I want to remove all references to the utils. There's no problem in directly calling the Superbase SDK in general, but I don't want to do this here anymore. And so I write my own const on sign out, probably an async function, yes. And I want to use on sign out here on press instead. Okay, and within on sign out, I now have to disconnect correctly from PowerSync. Not only like disconnect or sign out from Superbase, but also from PowerSync. So I will call await PowerSync dot disconnect and clear. There's also just disconnect. If you check out the docs here, it says disconnect and clear the database. Use this when logging out. The database can still be queried after this call, but the tables would be empty. To preserve data in local only tables, set clear local to false. That's not really relevant to us. But after this, I also want to make sure I correctly sign out from Superbase. So again, through the Superbase connector, through the client that we initialized in there, we call sign out. This is pretty much just like a wrapper around this. It doesn't hurt to do this anyway, to like have your own wrapper around Superbase in some cases if you want to switch this out. Cool, now we come to the last part, that we want to load our data not with a Superbase SDK anymore, but directly from my local database and keep it in sync using PowerSync. For that, again, I will remove the reference, which will turn some parts of my code red. And do we want to fix everything at once, or should we like comment out some stuff? I mean, it's just 4 instances, so let's just fix this, okay? As always, I want to bring in now my hook here, use system. So that's why we created this in the first place. And at this point, I will also need my UUID function. Additionally, we will now make use of Kuselli. As we said before, normally you would see now something like select star from like real raw SQL statements that you can actually also watch with PowerSync, which is pretty cool and impressive. But we're going to use Kuselli now. So this is why I also want to bring in my table name from the app schema. Okay, so let's get started. Inside load to-dos, why is this sorted like this? Why is add to-dos in front of load to-dos? This doesn't make sense to me. Okay, load to-dos currently looked like this. And honestly, it's just getting easier now. Okay, so I will get rid of this. And to load all my to-dos, I will try const result equals await database. Okay, so database is from the use system hook. It's like my local database that is in sync. Select from now follows the table name. So I got that string, which is the to-dos table. And I want to select all. And then I finally need to wrap this up with execute. This is the line we need to call to load my local to-dos. And of course, I should call set to-do with result, which is my state. Who's complaining about the result argument of type task screen is not assignable? Oh, I love TypeScript. That's so fun. Actually, the PowerSync schema here should have a to-do. So I should be able to get the to-do here instead of the interface. And then this works. Okay, so we're using the interface from the app schema now instead of like my local interface here. That's better. In the logs, I now see this result. You see this down here. React is now simply mad because, I don't know, something is wrong or off with the format of my to-dos, but that shouldn't be a problem because we see result ID is complete, task test. This looks good. So we just need to fix this, that error text strings must be rendered within a text. We should probably go down. Where is my index? Okay, we do set my result like this. And then we can check out how we render this. So we still have the flat list. We pass in my to-dos. That shouldn't be a problem. So let's check out the render row. This is getting an item. This is expecting a to-do. Then we have the item here. That should actually be fine. I think is complete is now, is complete is now a number. Okay, so is complete here is 1 or 0, so not a Boolean. That means I should probably check if item is complete is equal to 1. Then I will display this check mark. And then voila, it's done again. However, maybe the Apple style swipeable row is also mad about this. I think this is also using is complete 0 and is... Okay, that actually looks good. So I can mark this as done. Okay, good. That should be fixed. Now, let's see how we can add something, because right now we are not adding any data. And this is going to be interesting. So this was our previous code. I will simply remove this and we can rewrite this. First of all, I want to get the user ID so I can correctly attach the new object or the new to-do to a user. We're going to use our Superbase connector. As I said, this is like the instance we want to use to get our data, and I can call the fetch credentials, which simply gets our Superbase auth session and then returns all the relevant information. With that in place, I also want to create a to-do ID. So this is the time where the UUID package finally comes into play. And then I can insert that data into my database. So await database, insert into. And again, this is using Kuselli and makes it a lot easier. My values are, can you figure this out? Okay, ID is the to-do ID. The user ID is the user ID. Is complete will be set to 0, and the task is my task. Shouldn't it be like, where is it? To do? Is it a to do? Oh, it's actually a to do. Yeah, well, then it's like this. That executes this. Then I want to set my task input to an empty string. And I want to call load to-dos to refresh my list. So the watched query from PowerSync, as far as I know, does not yet work with Kuselli directly. However, let's see. In theory, this should now add a to-do, and at the same time, it should add the data to Supabase. If we did everything correct, this would be like the major breakthrough and success. So with local sync, let's add this. Oh, it's coming up. This feels so good when everything comes together. You don't see the benefit of this right now, but we're gonna get again to that in a second. Let's just wrap this up by implementing the last two functions. These are pretty easy. So update and delete. Deleting a to-do is just calling await database, delete from my table where ID is equal to the to-do ID. Again, this is getting pretty easy. We don't really need the result here, so we can like remove this. And to update my to-do, this is also pretty much the same, and it's actually getting shorter. So the new code would now look like this. Update table, to-dos table, where the ID is equal to the to-do ID, and set is complete to the opposite of the previous one, and execute that query. So let's again see this, play around. I want to mark my test as done. I actually don't know yet. Test is marked now as true. Let's see, I want to mark this as undone, and it changes to false. Now what happens if we turn out the network? So I got the network link conditioner. I will set this to on. This hopefully won't break my video recording, no, but it makes it kind of hard to work with like a real physical device. So let's try. If I now do another locally added to do. Oh, what's that? My app works pretty good still locally. And another one. This is like instant. Oh, this is so cool. And I probably want to like remove this one. So I'm basically offline with my application and I can use it the same way, even better than before. When we saw initially the Superbase example, there was a little delay from clicking that button and seeing the item appear in the list. It wasn't really noticeable, but this is just like a super simple to-do object we're adding. If you're adding more, if you're using storage or something, there will always be like a few hundred milliseconds of a delay that's noticeable. But what we see in here is that this is instant. This happens locally in like instantly. What we see as well is that, well, I'm probably not connected to Superbase right now because my network link conditioner is making me go offline. But what happens once I go back? I will turn this one off. I probably lost my WebSocket connection on this page here. I don't know if Superbase is smart enough to refresh this. I don't assume, so let me do a refresh. And we see everything is synced. So all the stuff that I added while I was basically offline is now synced back here, because we have successfully added PowerSync as the sync layer to our application, which now helps us to use this app completely offline, but at the same time still maintain the connection to Supabase through this PowerSync backend connector in which we've set up the Superbase connection. So when you go offline, you continue to use your app, everything is stored in SQLite instantly on the device, everything changes, and once you come back online, the Superbase, the PowerSync sync layer will take care of uploading all the stuff to your connector, and will then use this upload data, will go through all the transactions and execute them on the given database, which in this case is Superbase. But it of course could also be any other kind of Postgres database. So I really hope you were able to completely follow through on this project and you took it from the basic steps of the Superbase standard example to this new PowerSync example. And the ultimate test is you can now remove the utils folder with the Superbase connection we had before. So there's no traditional Superbase connection going on anymore, and we're relying entirely on PowerSync as the sync layer between our app, SQLite, and the Postgres database. Alright, and that's it for today's tutorial. I really hope this gave you an insight into how you can restructure your React Native application with PowerSync to implement the local first paradigm shift. Again, check out the first video I did on the general topic of local first and offline first and how it can help to improve your application. This is really not something that's like available only to the big companies anymore or really unimportant to you. There are many small and big benefits to making sure your application works instantly in a snap and like is just a lot better for your users, even if you think like they will always have an internet connection, because there are many more things that can be improved even in those cases. Again, thanks to PowerSync for sponsoring this video. I highly enjoyed working with this. There's another video coming up in the future on more examples of using PowerSync, and if you got any questions about the implementation, the SDK, or how all of this works together with probably also other databases, let me know in the comments and I'm happy to answer this, or the PowerSync team will definitely join in. Also, a reminder again that all the code is available for free. Link below this video to the repository. There's the initial app branch that you can check out for the Superbase example, and then there's the main branch which holds the code, basically the final code that we implemented in this tutorial. So go check it out, let me know what you think, check out PowerSync, and I will catch you in the next video. So until then, happy coding, Simon.